We're talking about Newton's second law this time. The objective for this is that students will be able to describe Newton's second law and net forces. You will need something to write on and something to write with. Let's get started. The definition of Newton's second law is the acceleration of an object is directly proportional to the force acting on it and inversely proportional to its mass. Meaning, in other words, the more force there is on an object, the more it accelerates. That's the direct proportionality. They both increase. And inversely proportional kind of means the opposite. So the more mass something has, the less it accelerates. Which kind of makes sense if you think about it. It's more massive, so it's harder to get it to change its motion. It has more inertia. So the equation typically looks like this, which, ignoring that funky looking symbol at the beginning right now, it's force equals mass times acceleration. That funky symbol that looks like a sideways capital M or a weird looking E is the Greek letter sigma, which means total in math, or in this case net. So therefore, sigma F is the net force measured in newtons. So you won't hear me say sigma many times. You'll usually just hear me say net force. So net force and sigma F, the same thing. Either way, they're the total amount of force acting on an object. More to come on net force in a couple slides. But the M stands for mass, and that's measured in kilograms, and the A stands for acceleration, measured in meters per squared second, just like we've been doing. So let's suppose a cart is being accelerated by some amount of force. If a mass is suddenly dropped onto the cart so that the total mass of the cart doubles, what happens to the acceleration of the cart if the pulling force remains constant? So the mass is getting more. So if you said that the acceleration would double because the mass doubles, that would actually be incorrect. It's halves. Because mass is inversely proportional to acceleration. So net force is the overall force on an object. Forces in the same direction are added together, and forces in the opposite directions are subtracted, just like vectors. Actually, force is a vector, so same thing. So if we had this box here, and there was 3 newtons being pulled to the left and 5 newtons being pulled to the right, the overall net force would only be 2 newtons. Since the 5 is bigger, then it's going to move that direction. So it'll move 2 newtons to the right. Equilibrium is a special circumstance when the net force on an object is 0. Or in other words, all the object's forces balance out. And the question I have on here is, could this happen if an object is moving with constant velocity? Do you think that something moving with constant velocity can have no forces acting on it? And the answer is absolutely. Having a net force of 0 just means the acceleration is 0, which means your velocity wouldn't be changing. So by definition, a net force of 0 means you're moving with constant velocity. So that's it for this portion of the notes. Be sure to take the Edmodo homework quiz and bring your notes with you to class next time so you can take the note quiz. Thanks for watching.